In this mini tutorial, we're going to find out more about the nature of redox reactions, such as the one written on the screen here. And any redox reaction actually comprises two separate half reactions. One of these reactions is an oxidation reaction, and the other is a reduction reaction. So in the case of the reaction written here, the redox reaction here, there are two half reactions. One involves zinc and looks like this. So it's an equilibrium reaction in which zinc goes to zinc 2 plus and gives up 2 electrons, and as such it becomes oxidized. And then the other half reaction involves copper, and in this case the copper picks up 2 electrons to become copper like that. So that's becoming reduced. So we see zinc losing 2 electrons, and the loss of electrons is oxidation. We see copper gaining 2 electrons, so copper becomes reduced. And it's important to realise these two reactions, these two half reactions, are coupled, linked together. The electrons have to have somewhere to go, so the electrons that are released by zinc when it's oxidized are then picked up by the copper. So effectively then, the zinc is reducing the copper, and it itself is becoming oxidized in the process. So the zinc is called the reducing agent. But you'll notice this is an equilibrium reaction. So an alternative would be to consider the reaction in the opposite direction. So you'd have zinc 2 plus here, and copper going to zinc and copper 2 plus. So the question is, how can we tell in which direction the reaction goes, whether we're likely to see the forward reaction like this, in which zinc is oxidized and copper is reduced, or the back reaction as written here, in which the zinc is reduced and the copper oxidized. So in that case we would see the half reactions of zinc 2 plus picking up 2 electrons to become zinc, and we would see copper becoming copper 2 plus. That's an aqueous there. So in this case, it's the copper giving up the electrons, which are picked up by the zinc. So the copper is becoming oxidized, and the zinc is becoming reduced. And to answer our question about which direction the reaction is most likely to happen in, we have to consider the reduction potential. And for this, we consider these two reactions. We consider zinc being reduced, and we consider the equivalent of copper being reduced. And we then look at the reduction potential. And the reduction potential is a numerical value. In the case of the zinc, it's minus 0.34. In the case of the copper, it's plus 0.34. And the most likely reducing agent, the one that's most likely to give up electrons to be oxidized, is the one with the most negative reduction potential. So in this case, it's the zinc. The zinc has the most negative reduction potential. So when it's in reaction with copper, the zinc is more likely to reduce the copper rather than the copper reducing the zinc. In other words, the zinc is becoming oxidized and the copper is being reduced, which is what we see at the top here when the reaction happens in this direction. It's important to realise that when we're looking at the reduction potentials, what we're seeing written down here is zinc being reduced. But as I say, when the zinc is acting as a reducing agent, the reverse is happening. The zinc is actually giving up electrons.